Hello and welcome to this online video lecture about Hess's law. Hess's law is a fairly advanced thermochemistry concept that you might encounter in like a first year college chemistry course. Um, it's a pretty important concept if you're going to be studying chemistry in any kind of detail, but it's really not as challenging as it might sound as first. So if you have a little patience and stick with it, I'm sure that this is something that almost anybody can learn how to do. So by the end of this video lecture, what you should be able to do is take a given reaction and then take the part reactions for that, like the steps, reactional steps for that, modify them, and then add them together to find the enthalpy of the first given reaction. So when we're all done with this, you should be able to take partial reactions, add them together, and calculate the right amount of enthalpy for a given reaction. So if you watch this whole video and you still have questions, make sure you check with me in class and we'll sit down and go over it, and I'm sure you can get it. So basically Hess's law, like I just explained, says that every reaction can be thought of as a series of steps or partial reactions, and if you take the enthalpy change for a partial reaction and you add up all of the partial reactions enthalpy change, you'll get the enthalpy change for the total reaction. So if you know the total reaction, and then you know the partial reactions, and then you know the enthalpy change for each partial reaction, you should be able to figure out the enthalpy change for the original reaction, which is a very useful thing to know in chemistry. How is that energy changing? So what I'm going to do is I've got a few examples here, and I think I'll have two. I have two examples, and we're going to work through both of them. It uses some concepts from the previous advanced quiz. Make sure you can modify these thermochemical reactions because you're going to have to do that to get this all to work out. And we're going to have to go through the first example pretty slowly, and then after explaining some concepts in detail after that, I'm going to go through the second one a little bit faster. It's just a little bit more advanced example. So. All right, so here, let me just, oh man, it's way down there. Let me grab that, pull it up. Oops, wrong layer. Burp. Okay, so let me grab that and pull that out. There we go. This is what you can expect to see kind of like on the quiz. This is a very typical example of a Hess's law problem. So let's just look, kind of pick it apart here. You've got the original reaction, right? And it says calculate the enthalpy for this reaction. So this is the reaction that we want to know the enthalpy for, as you can see right here with all these question marks. And then it says, given the following thermochemical equations. So basically, what these are down here, these are like partial reactions that we can manipulate and then add together to get the original reaction over there. And that's basically what you have to do. You have to look at each one of these and say, okay, so first of all, how do I have to change these so that I'm getting the reactants and products from my original reaction, step one. And then step two, can I add them together and does everything cancel out correctly? And if that's the case, then you can go ahead and add the enthalpies up, and that should be the enthalpy change for the original reaction. So let's just take a peek at this, and we can kind of figure out what's going on here. As I work through it, hopefully it kind of becomes clear. So let's look at this very first. Let me use a different color here. I don't like the. There we go. I'll use the blue. So this very first partial reaction that's given to us, it's got C2H2. It's got 5 halves moles of O2, it's got 2 moles of CO2, and then it's got 1 mole of H2O. So we're just going to kind of look at that reaction and see, are any of those things in our original reaction? And I can see that there's C2H2 up here, and then it looks like that's it. So basically, we need to modify this equation so that the C2H2 is on the same spot of our original reaction. So in the original reaction, the C2H2 is the product. So in this partial reaction, we have to make it a product as well. So what I'm going to do is I'm going to rewrite that equation, that reaction, so that it's in the right order. So that was going to look like 2CO2, and then that's H2O, and then that's going to make, what I'm basically doing is I'm flipping these because I need C2H2 to be a product. And in the reaction as it's given, it's not a product, it's a reactant. But in the reaction that we care about, it is a product, so they have to match. Hopefully that makes sense. And then we've got the, the 5 halves of O2. All right. So now I have to look and see I've got that on the right side. Now I have to check and make sure that the amount in moles is the same. So in my original problem, I need 1 mole of C2H2, and in this one, I need 1 mole of I'm going to make 1 mole of C2H2. So in the original problem, we're making 1 mole of C2H2, and because I've reversed the order, we're making 1 mole of C2H2. Now, if you remember from the previous advanced quiz, if you reverse the order, that reverses the sign on the delta H. So that means that the delta H for this is going to switch from being negative 1299.5 to positive 1299.5. And that's going to come into play later on. That's going to be very important. Okay, so that's step one. I've flipped that one so that it's on the right side now. So now let's look at the second reaction. What do we got there? Let's see. We got carbon. Ooh, and I notice I have carbon up there as well. Oxygen, there's no oxygen in the original reaction. And then carbon dioxide, and there's none of that in the original reaction. So what I'm going to do is I'm going to try to write this, rewrite this equation so that I have carbon on the right side of the reaction, and I have the right amount of carbon in moles. So in our original reaction, carbon is a reactant, and in this partial reaction, carbon is a reactant. So that checks out. That's good. But unfortunately, in the original reaction, we have 2 moles of carbon, and in this partial reaction, there's only 1. So what we're going to have to do is we're going to have to modify this reaction by multiplying everything in it by 2 moles. So we're going to go from having just carbon to having 2 moles of carbon plus 2 moles of O2, and that's going to make 2 moles of CO2. Bam. And then if we multiply everything in the reaction by 2, then we have to multiply our change of enthalpy by 2, our delta H by 2. So let me just pull up a calculator just to make sure I don't make any silly math errors. Let's see. Oh, that must be left from the last lecture. So we've got negative, we got to put the number in first, 393.5, and it's negative, and we're going to multiply it by 2. So we're going to get 787. So that's going to be negative 787 kilojoules per mole. So our delta H, change in enthalpy, is negative, what did I say? I forgot already. Jeez, oh Pete, 787. So negative 787 kilojoules. All right, beautiful. So we have 2 moles of carbon in our original reaction. We modified this partial reaction now to have 2 moles of carbon as a reactant as well. So that's good. So now we have to look at the third one. So in the third one, we've got H2, and there's H2 in our original reaction, so that's probably the match. Then we've got O2, that's not up there, and then we've got H2O, and that's not up there. So we have to have H2, and it has to be a reactant. And we have H2, and it's a reactant. And in our original equation, there's 1 mole of H2. And in this equation, there's 1 mole of H2. So I'm just going to go ahead and rewrite that here. So we've got H2, and then we've got half of a mole of O2, and that's going to make 1 mole of H2O. And then we didn't change that equation at all, so we're going to stick with the delta H, change in enthalpy of negative 285.8 kilojoules. All right, now we're going to check. So when you've modified all of your partial reactions, you really want to check and make sure that everything checks out and you can actually get your original reaction from them when you add them together. And here's how this works. Basically, if you have the same thing in one reaction as a product that is a reactant in the other, then those things basically cancel each other out. Excuse me, sorry about that. My nose is running a little bit here. So for example, in this first partial reaction up here, we've got H2O. And then down here as a product, we have H2O. And because we have the same substance, the same amount as a reactant in one and a product in the other, in other words, they're on opposite sides of the yield arrow, right? One of them's over here and one of them's over here. They cancel out. Bam. Beautiful. Okay, so let's see if we have anything else that cancels out. I notice I have 2 moles of CO2 over here as a reactant, and I have 2 moles of CO2 over here as a product. So those are going to cancel out. Bam. And then let's see, is there anything else that's going to... It looks like we have a bunch of O2 all over the place. So I have 2 moles of O2 here, and I have 1.5 moles of O2 here. So if we think about that, how many, let's do it in halves, because I'm looking up here and I've got 5 halves of O2, and that kind of, So if I have 2 moles of O2, how many halves is that? 2 is 4 halves, right? And then down here I have 1 half. Well, 4 halves and 1 half is 5 halves. So I have 5 halves moles of O2 as a reactant when I look at both of these partial equations. And then when I look at this partial equation up here, bam, I've got 5 halves of O2 as a product. So that cancels out. This 5 halves of O2 cancels out with this 5 halves of O2 that you get when you add those two together. Wow, I have crossed a lot of stuff out. So what are we left with? Well, let's see. We've got a product of C2H2. All right, that sounds good. And then we've got a product of 2C2, or I'm sorry, a reactant of 2C, not 2. Oh my gosh, could I have messed that up anymore? So we have a reactant of 2 moles of carbon, and then we have another reactant of 1 mole of hydrogen. And so if we add all that up, we've got 2 moles of carbon reacting with a mole of hydrogen, making a mole of C2H2, which is exactly what our original reaction was. Perfect. So now all that's left is that we're going to, just like we had to add the reactions together, now we're just going to add the delta H's together. So let me pull up my calculator again. Bam, I'm going to clear this out. So I've got, what do I have? 1299.5, and then we're going to add to that 787, and that's negative, which is super duper important that we get the sign right. And then we're going to add to that, what do we have? 285.8, and that is negative. Again, the sign is super important. And when we add all that up, we get 226.7. So that means that our answer, the final answer now, is 226.7. So delta H for our original reaction is 226.7 kilojoules. That is the answer. 0.7. There we go. So there we go. And I worked through that in depth that time because that's the very first one that we did. So let's look at a little bit more advanced one. It's got some crazy stuff going on with the fractions. It's a little bit more complicated. So let's get rid of this one, turn that one off, and I'm going to bring in the one that's a little bit more complicated. I've got, what about, let's see. I hope I have enough time to do this. Okay, so bring this one in. Okay. So I'm not going to go through it as detailed as I was before. I'm just going to kind of run through it a little bit more quickly. So this time I put the original reaction down at the bottom. Oops, sorry about that, which might be kind of confusing. Let's see. So NO2, I'm looking for NO2. Okay, NO2 right here, and it's 2 NO2 here, and it's 3 NO2 here. So this is where it gets a little bit more complicated. So not only do I have to flip it, but I have to get 3 moles of NO2. So I'm going to divide everything by 2 in that equation, and then I'm going to multiply it all by 3. So we're going to get 3 moles of NO, because I'm going to divide it by 2 and then multiply it by 3. And then I'm going to get 3 halves of O2. And then I'm going to get, that's going to make 3 moles of NO2. But it's on the wrong side. So I'm going to flip it. So it's going to be 3 moles of NO2, making 3 moles of NO and 3 halves of O2. So what did I do? I divided by 2. I'm going to write this down. I divided by 2, I multiplied by 3, and then I flipped it, right? So that's what I have to do to the delta H. So the delta H there is 116, and it's negative. I'm going to divide it by 2. I'm going to multiply by 3, and then I'm going to flip the sign. And so I get, for delta H, I get 174. All right. So that's how I'm going to modify that one. Now let's look at the second one here. We got N2O2, H2O, and HNO3. And so I see I have HNO3 in my final one. I also have H2O in my final one, so hopefully that all shakes out. I'm going to focus on the HNO3 because that's the only place that I see it up here. So there's 4 moles of it as a product in that equation, but I only need 2. So I don't have to flip it, but I do have to divide the whole thing by 2. So I'm going to get, I'm going to N2, I'm going to get, oh man, I'm going to get 5 halves of O2, and then I'm going to get, let's see, I'm going to get a mole of H2O, and that's going to make 2 moles of HNO3, and then I divided everything in that by 2, so it's delta H I have to divide by 2. So let me pull up the calculator real quick and clear this out. And we're going to do 256, and that's negative, and we're going to divide it by 2. And our delta H for that is going to be negative 128. All right. Okay, one more equation to go here. So in this last equation, what do we have? We have N2, we've got O2, and we've got NO. So what do we have? We definitely have NO in our last equation, and it is a product. I don't see any of the other ones in the equation, so hopefully this is going to work out okay. It was just one of those. So this is where it gets kind of tricky. So this is where you have to be careful. If you look at this reaction right here, I already have 3 nitrogen monoxide as a product, 3 moles of nitrogen monoxide. But in my final equation, I only want 1. So that means I have to cancel some of that out. So I basically want 2 moles of nitrogen monoxide as a reactant in an equation. Well, that would work in this equation, but right now it's a product. So that means I'm going to have to switch it. So I'm going to switch that. I'm going to go 2 moles of NO as the reactant. Oops, sorry, not NO2. That's my bad. Let me get that out of there. So 2 moles of NO is the reactant, and it's going to produce N2 and O2, and then I'm going to flip the sign, and the delta H is negative 183. Now let's see what we can cancel out here, and hopefully I did all this right. I didn't make too many mistakes here. Now remember, this equation isn't the final version, so I'm just going to cross that out so I don't get confused. I get confused easily. So I've got 3 moles of NO. That's not going to cancel with anything. So I've got 3 moles of NO here, and I've got 2 moles of NO here. So those are going to cancel out, and that's going to leave me with 1 mole of NO. All right. And then I've got, what do I got? I've got, okay, this is where it gets a little confusing. I have 3 halves of oxygen over here, and I have 5 halves of oxygen over here. So if I cancel out 3 halves of oxygen with 5 halves of oxygen, that's going to leave me 2 halves of oxygen, because 5 minus 3 is 2. So that's basically what? That's basically 1 mole of oxygen there, right? So I'm not sure if I can, that's going to maybe erase the whole thing. Let's just, whoosh. All right, so I'm going to erase this, and that canceled out, and now we have just 1 mole of oxygen there. And now we've got a mole, let me switch back to my pen. We have a mole of oxygen down here, and that cancels that. And we have a mole of nitrogen down here, and that cancels that. So what are we left with? Hopefully what we want. We've got 3 moles of NO2 as a reactant. Check. We have a mole of water as a reactant. Excellent. And then we've got 2 moles of HNO3 as a product. And then what else do we have as a product? We have 1 mole of NO as a product. And so that all checks out. So now all that's left to do is to add up the delta H's. So that's good. I'm glad that worked in the first try there. Sometimes these can be a little bit tricky. So, okay. So, what do I have? I've got 174 plus negative 128. So, oops, crap. So, 128. Make that negative. Plus negative 183. And what do I get? I get negative 137 for this one. So, the delta H for this original reaction is negative 137. Yes, I know that's black. Negative 137. That's kilojoules per mole. So there you go. This is a little bit more complicated, but with a little practice, almost everybody can learn how to use Hess's law to find the delta H, the change in enthalpy for a reaction using its partial reactions. So thanks for watching. If you've got questions, this is a complex one, so if you've got questions, please feel free to ask me in class, and we'll talk to you later.